This is Dr. Moberly. We're going to look at integration by parts using the tabular method for a convolution problem. And I've set up one that will require multiple integration by parts. This is in the style of Kresig's section 6.5. And the inverse Laplace transform of this rational expression, the first step is we want to factor it into two things that look like the terms in the table. And terms that would be in the table would be 6 over s to the fourth and 10 over s squared plus 100. And we're going to have to multiply this by 1/6 to get it out. This is going to be 3 factorial over s to the 3 plus 1. In case you didn't recognize it, the inverse Laplace transform of this guy is going to be t cubed. The inverse Laplace transform of this guy is going to be sine 10t, and the scalar just comes through. So what we need to do is convolve t cubed sine 10t, and that's where the integration by parts is going to come in. So we're going to integrate 0 to t of tau cubed times sine of 10 t minus tau, t tau. And I'm going to set up the integration by parts using the tabular method. So here's the table. Tau cubed is the starting point. Sine 10 t minus tau is the other starting point. And we're going to differentiate. And we're going to integrate. And we're going to keep doing it until the term disappears. 6 tau, 6, and 0. And this is just a reminder we need the same number of entries on the other side. The integral of sine is negative cosine and we're integrating with respect to tau, so we're going to get a negative 10 out of that integration effort. Now we integrate again, sine 10 t minus tau. We're looking at negative 10 squared here. Change sign again. Hit cosine 10 t minus tau. And negative 10 cubed. And lastly, we've got sine 10 t minus tau and negative 10 to the fourth power. All right, now the next step we do with the tabular method is line up the terms using this diagonal connection and alternating signs. And this is a way of doing the u v minus integral v du, and then this becomes a v u minus integral u dv. Oh goodness, it's just the repeated integration by parts is going to work out. And we're going to, actually all the integration has been done. We just need to evaluate. So we've got tau cubed times minus cosine 10 t minus tau minus 10. That's going to be evaluated from 0 to t. We've got minus 3 tau squared times a negative sine 10 t minus tau over minus 10 squared. I'm going to put parentheses around that so that we remember that it's not a subtraction but a multiplication, plus 6 tau cosine 10 t minus tau over minus 10 cubed, and then a minus 6, that's 0 to t, minus 6 times sine 10 t minus tau over minus 10 to the fourth. And that's evaluated from 0 to t. Looks like we've got 8 terms here. However, the second term here is 0. Second term here is 0. Second term here is 0. And the first term is going to be, in this case, you've got t cubed times minus cosine 10 of 0 over negative 10. That does have a value. And that works out to be minus t cubed over 10. So this is the at t value. This is at 0. This is going to be a sine minus sine of 10 times 0. And this value is also going to be 0 at 0 at t. All right, so nothing drops down from there. This is going to be a 6t cosine 10 times 0. Again, you're going to get a 1 over there. Negative 10 cubed. And this is a plus sign, so we're looking at minus 6t over 1,000. And that's at the t. Tau goes to t, so t minus tau goes to 0. And then the last two terms, we've got at t sine, we've got a sine of 0, so that's going to go to 0. At 0, we've got a sine minus 6 sine 10 t all over 10,000. And that's a minus sign. So that's the third term that comes down. We've got 3 expressions. I think we forgot a 1/6. And it's going to be minus t cubed over 10 minus 6t over 1,000 and minus 6 sine 10t over 10,000. And I guess we could factor out the 6. So it's minus t cubed over 60 minus t over 1,000 minus sine t, 10t over 10,000. And that's it for our y of t.